Welcome everyone to another episode of Practical Programming. Today we're going to be solving a problem related to Collatz Conjecture, and this details for the problem looks like this. We would be given a number, any number n, it will be positive, and we need to find out can we reach 1 by performing following operation any number of times. If n is given as an odd number, we will multiply that by 3 and plus 1, and we'll save that as a new given number. And if it happens to be even, we divide that by 2, and we have to keep performing this operation until we reach 1. And our code should deduce that is it possible to reach 1 if we keep performing these operations on it. So if you are given with input 21, it should say yes, that we can reach 1. Let's try to understand how this is gonna look like. So if we are given 21, because it is odd in number, we have to multiply that by 3 and plus 1, so we get 64, and we get an even number, so we do this, divide that by 2, and we keep performing these operations over and over and over and over, and finally to the point we get 1. So as we understand from this is 21 is reachable to 1 if we keep performing this operation. For odd number, multiply the number by 3 and plus 1, and for even number we divide that by 2, and ultimately we'll reach 1. So result should say yes. For those who already know what Collatz conjecture is, they might be laughing at my video, and you have a good reason. Let's not spill the beans for those who do not know that. I'm not going to solve this problem. It's because if you were to try to do that, you'll find out no matter what number you're given with, you always end up at 1. We really don't know why and how it works. You might think we have a pattern for it, but we actually don't. It's been said that our mathematics is not ready for a problem like this, and the problem comes from Lothar Collatz, and it's literally named after him. It came in 1937, and we still don't have solutions for it. If you do, please let everybody know. It's $500 question. It's a joke. You'll get it later. So let's try to solve this question. I'm not sure why do I keep saying I'm gonna solve this problem when I know I'm not going to. Okay, so for the previous problem I added some documentation, and I'm gonna provide the link on the video so you can look that up. And let's try Collatz problem for now. Collatz Conjecture. Oops, my bad. Okay, I know I have the weirdest name ever, but I don't know what to come up with when it comes to name of the classes. Public static void main. I have my main function. Let's check that out real quick. I know this sounds stupid, right? Okay, this project is still running. I like to check that a couple of times a day. Funny, right? Given number. Oop, my bad. Can't spell anymore. Given number, and it's gonna run all the way to 100. So what I'm doing is, because I know the answer is always going to be 1, so we're going to run this program and try to show that no matter which number I pick, any given number between 2 to 100, it will always gonna reach to 1 no, if I keep performing those operations. So let's say it's out given number. Do I really have to test this? So I can go from 2 to 100. Let's write our code now. Okay, for given number is equal to this, and we have to let's find out how many steps it takes for that given number to reach there. Okay, tab. What that /t does is gonna give a space between this content and anything after that I write. Okay, so I have to show you how it looks like actually. number of steps. Okay, and let's write a function name, or method, I would say, number of steps to reach 1. Okay, and we'll give this given number as an argument to that. I'm gonna do alt enter, and I'm gonna create this here. Okay, I spelled that wrong, so I'm gonna do shift F6, and so I can rename that function. Great. So we're gonna try to test if we are able to reach number 1 if we keep performing those operations, and we also count number of steps it has taken. We don't have to, but you know what, we might as well do that at this point. Step 0, initially it's going to be 0, and let's return that over here. Okay, so if I run this, it'll keep giving me 0. You know what, let's have a look at it. Oh, what did I do now? Oh, I need a plus sign over here. Sorry about that. See, this is why I keep running things. You may never know what I missed when. So for every number, give number of steps is all 0, because you know what, because I haven't been doing anything over there. So I'm going to use this loop called do while, is because I always want to start it. So if given number is not equal to 1, what it means is, if given number never reaches 1, keep running this. And I know if we follow our operations, it will someday reach 1. I know if you have a really huge number, you may never know how long will it take. So we need to find out if given number is an odd number or even number. Easiest way to check if a number is even is mod of 2 and 0. What it means is, if you divide the given number by 2, do you have any remainder or not? If you don't have any remainder, you should get 0. If this statement is 0, what it means is the given number is even. Else, and if there is a remainder you have, it means it's odd. Let me clear that out. Well, after reformatting, I would say given number is equal to, because it is even, we'll say okay, given number divided by 2, and we'll save that in the given number. Reformat again and say, oops, why am I writing that? Given number is equal to, and because when it's odd, let me look at, let us do this, given number plus 1. I could have written it in a shorthand manner, but I'm doing this so this equation looks like what we have in the operations we need to perform, so it would be easier to read the code. Okay, so what it does is, okay, we haven't incremented number of steps it has taken, so let's just do this. What it does is, this x actually increments this number. It's actually means this 1, or you could just say it's equal to step plus 1. It's the same thing. Okay, let's run this our code and see what happens. So if you see, if you are given a number 2, it takes only one time, because it's even number, to divide that by 2 and you'll get the 1, and number of steps it taken to reach to 1 is 1, and the maximum it takes is 118, 110, I believe. If the given number is 1 to 100, the maximum number of steps it takes is 497 to reach to number 1. So if we were never to reach 1, this will keep on running. As long as I have battery on my computer, it will keep on running, but it doesn't do that. No matter what given number is, it will always reach to 1, and so it will break the loop and it will return the number of steps it has taken. So I haven't solved the problem, I know that. I don't have the answer for it, guys, but if you do, please let everybody knows. Okay, thank you so much for your time, and please subscribe, and you have a good day.